So you understood, I think, how we got this. See, we know U is equal to half into delta L, correct? But in the place of S, we know Y is equal to F by A delta L by L, correct? So I can write YA delta L by L is equal to F. So in the place of F, if I substitute half into YA delta L by L, actually this is for energy stored, not per unit volume. Now the question asked over here is energy stored per unit volume. So here actually volume will be there. Volume is nothing but area into length. Per unit volume means divided into delta L divided by area into length, correct? So area will get cancelled. Per unit volume, energy stored per unit volume is half into Y into delta L by L whole square. Delta L by L is nothing but strain into Y. So strain they have given it in the form of E. So therefore I can say U is equal to half into, actually energy stored per unit volume is equal to half into Y into E square. Option D. I hope you understand. See, this one solving in the exam is and all is of waste of time. So you should know on your own before without solving itself. You should know energy stored per unit volume is half into stress into strain. Actually it is half into Y into E square. Instead of stress into strain, I can say this is for energy stored, not per unit volume. If it is per unit volume, Y into E square. Strain in Y into strain is nothing but delta L by L is square of that one. Understood? Next. The next problem is 14th one. Can you help me for the 14th problem? A uniform speed bar of cross-sectional area A and length L is suspended so that it hangs vertically. The stress at the middle of the bar is, rho is the density of the steel. One bar is there, okay. Uniform speed bar, cross-section area is A and its length is L. It hangs at the center. What is the stress? At the center you have to say, correct? Tension is nothing but weight of the bar at the center. Weight at the middle. What is the weight at the middle? Density, tension, weight is nothing but mass into acceleration due to gravity. But they have not given you any mass. We know mass, density is equal to mass by volume. Since they have given you density, mass is equal to density into volume. So therefore I can write rho Vg is nothing but tension at the middle. Correct? Volume also they have not given you, but they have given you the length. So area, volume is nothing but area into length. So rho into area A, length is L. But now at the middle, no? So therefore length is L by 2 into G. They have asked you at the middle. So uniform cross section, stress at the middle since they have asked. So length is, full is L, but half is L by 2. So rho L by 2 into G. Answer. That is nothing but our stress at the middle. So therefore I can say stress is nothing but tension per unit area. Tension per unit area. Tension is rho A L by 2G divided by area. Area gets cancelled. So therefore stress is equal to rho L G by 2. Option B. We found tension. There is a relation between tension and the stress. Stress is nothing but tension per unit area. Therefore substitute this value divided by area. Area gets cancelled. So stress is equal to rho Lg by 2. Next, 15th problem. Can you help me for the 15th one? The Young's modulus of these brass and steel are respectively: a brass wire and the steel wire of same length are extended by 1 millimeter under the same force. Radii of the brass and steel wires are RB and RS respectively. Then, relation between RB and RS they have asked. Okay, Young's modulus of steel and brass is given. So we have to use the formula of Young's modulus. FL by A delta L. Okay. They have been extended by a length 1 millimeter. Both are extended by length 1 millimeter. So I can say delta L is equal to 1 millimeter under the same force. If the force is the same, okay, F is the same for both. Radius is also same. Correct? No. You have to calculate radius itself, RS and RB. But in the formula there is no radius. So what you have to do? You have to say area is nothing but pi r square. So FL by A, instead of that pi r square into delta L. Correct? For the brass, YB is equal to F brass by steel. Correct? Okay. F is same, length is same, area pi RB square, delta L is same, FL pi RS square square delta L. So which and all are same, they will get cancelled out. So YB by YS is equal to RS square by RB square. So I can say RS by RB the whole square is equal to Young's modulus of B, brass, is 1 into 10 to the power 10 divided by steel, 2 into 10 to the power 10. This will get cancelled. 1 by 2 is nothing but RS by RB is equal to. So what I can say? RS by RB the whole square it is. We have RS by RB. Correct? So therefore I can say RS by RB is equal to square root of 1 by 2. Then I can say RS is equal to RB divided by root 2. Option B. Sixteenth one. A uniform cylinder rod of length L, area of cross section A, Young's modulus Y, is accepted upon by the forces in the figure. Okay, see that figure carefully. Here they have given 3F, center F, here it is 2F. The length of this one is L by 3. They did not say it is from the center or what. Okay, full length is L. If length full is L, then this part is 1 plus 2, 3. 2L by 3. Correct? This length is 2L by 3. Okay. For the length 2L by 3, they have given you Young's modulus. Again use the same formula. Y is equal to, what is the formula? FL by A delta L. Correct? Now what is the force for this one? First one. What is the force? 3F. Both side it is same side, so force will add it up. The total force of that side also is 3F. So therefore 3F into, what is the length? 2L by 3 divided by A into delta L. Is equal to Y. Okay. We want to calculate what? Extension or elongation, correct? So I have to calculate delta L. Elongation in the first one, elongation in the second one. Total elongation I have to calculate. So use this and calculate. How can we calculate? Help me. Y is equal to, or so I can say delta L1, for the first one it is. Okay, delta L1 is equal to 3F. See, 3 will get cancelled. So I can write directly 2L F. 2FL divided by AY. L2 is equal to, for delta L2, what I can say? What is the total force for this one? See, for this one, this is F, but this one is in the opposite direction, 3F. So total force is 2F. 2F. Correct? Okay. So 2F length is L by 3 AY. Now if you add, what is the answer we get? Can you help me for the answer? Two FL divided by AY is equal to 2FL by 3AY. Six FL plus 2FL. 6 plus 2, 8 FL by 3AY is equal to elongation. Yes, option D. Option D. Delta L is equal to 8 FL by 3AY. Next. So in this problem, what we have done? There was a full bar. Somewhere it was divided by length L by 3. Here F. Here 2F was there. And here 2F. Initially what you have to take? First part. Second part separate you take and solve. It will be easy. Length is 2L by 3. Force 2F. Here this force plus this. Sorry, here it was 3F. F plus F because same direction. So total 3F. For this one, this is F and this side it is 3F. So total force present here is 2F. Here it is already 2F for the length L by 3. This is how you have to divide it into two parts and solve, and then you have to add that length. Elongation you will get. 17th one. The density of the material at a normal pressure is rho. Okay, density is rho. Its density when it is subjected to excess pressure P is rho dash. Okay, you are subjecting it to excess pressure P is rho dash. Okay, when the excess pressure is given, density changes from rho to rho dash. Bulk modulus is B is bulk modulus of the metal. Then the ratio of rho dash by rho is, okay, rho dash by rho. Density is equal to mass by volume. We have to find out this one, correct? Density is equal to mass by volume. Mass is constant. So, mass by volume. So, density is inversely proportional to volume. So, therefore, I can say rho dash is proportional to 1 by V dash. And rho is proportional to 1 by V. If we divide these two, we get rho dash by rho is equal to V by V dash. Correct? V by V dash. Volumes we get. Increased volume, I will write it as V by V plus dV. Okay. If we take V outside, V by V 1 plus dV by V. V will get cancelled. So, rho dash by rho is equal to 1 by 1 plus dV by V. Now what we can do? What is dV by V? We don't have that formula, but they have given you the value of bulk modulus. What is bulk modulus? Expression B is equal to minus P by delta V by V. Or dV by V. So I can say dV by V is equal to minus P by B. Then I can write rho dash by rho is equal to 1 by 1 plus minus P by B. Where is answer? Do we have any answer? Yes, this becomes 1 plus or plus into minus is minus. So option A. What we have done? We have taken density of the material at normal pressure is rho. Then it is subjected to excess pressure P. Then rho density changes to P dash. So density is nothing but mass by volume. Mass will remain constant. It depends only on the volume. So inversely proportional to volume. So for this one, if we divide these two, we will get this one. V dash is nothing but increased volume. So V plus dV. We take V outside, so V gets cancelled, so therefore remaining is this one. Relation between the bulk, because they have given you the bulk modulus, so bulk modulus is this one, so I can say dV by V is equal to minus P by V. Substitute, we will get this answer. Next, 18th one. How can we solve this one? 18th one. The ratio of tensile stress to longitudinal strain. Stress to longitudinal strain is nothing but Young's modulus. It is nothing but Young's modulus, option B. Direct question it is. Next. Did you try all these questions on your own? Did you get the answers? Till now what we have solved, whether you got the same answers? How many of you got all the questions answered right? Yes. Next, 19th question. Wires A and B are made up of same material. A has twice the diameter as that of the B. Okay. If the elastic stretched limits are not reached, when each is stretched by the same tension, okay, same tension, the ratio of the energy stored in A to the energy stored in B. Energy of A stored to energy stored in B is what? The ratio you have to calculate. We know that U is equal to half F into delta L. Correct? But delta L, what we can write as, how can we solve this? Delta L can be written as half into force into delta L, we can write it as F correct. So therefore I will write FL by AY. Now half F square L by AY. We have diameter, same material, so Y is same, force same, same tension means force is same, length diameter, A has twice the diameter and thrice the length, sorry, correct. Use UA by UB is equal to half, F is same, L A by pi RA square Y. Half F square LB by pi RB square Y. F pi half Y will get cancelled because they are same. So what is remaining? UA by UB is equal to LA by pi RA square into LB. Pi also got cancelled. RB. Correct? Diameter is nothing but twice the radius. So RA is equal to 2RB. Length is LA 3LB RB the square 2RB square into LB R square 3 by 4. Option B 3:4. Understood? Option B 3:4. What we have done? UA by UB we have to calculate. Correct? What they have asked you to calculate? Ratio of the energy stored. So UA by UB you have to calculate. That is half U delta L, we know it. In the place of delta L we can substitute this value. Y is same for all. F is same. Only the changes is length and radius. That will remain. So we know diameter is nothing but twice the radius, 2RA, 2RB. But this is 2 times. So 2 gets cancelled. So RA is equal to 2RB. So in the place of RA I will substitute 2RB. In the place of LA I will substitute 3LB. So after substituting whatever is getting cancelled, cancel it. The remaining is 3 by 4. Answer is 3:4. Next. Option B. 20th question. How can we solve this? 20th question. The Young's modulus of the material of the wire is equal to Young's modulus stress by strain. What it is? Young's modulus is nothing but F by A divided by delta L by L. Correct? That is nothing but stress by strain. Young's modulus of the material of the wire is equal to stress required to increase the length of 4 times No, no, no. We cannot increase the length 4 times. Okay. Strain produced in it. Is it directly strain produced in it? Stress by strain. No, it is not directly equal to strain produced in it. It is equal to stress by strain. Half of the strain produced in it? No. Is it equal to stress produced to produce unit strain? If this is 1, strain is 1, y is equal to stress. So option B. Option B. Why it is option B? Y is equal to F by A in del by stress by strain. If strain is 1, y is equal to stress. So Young's modulus of the material of the wire is equal to stress required to produce unit strain. Next, 21. A solid ball of density half that of the water falls freely under the gravity from a height 19.6 meter and enters the water. Up to what depth will the ball go? Okay, ball has to fall to the water. This height is 19.6 meter. Neglect air resistance and viscosity effects in water. Okay, acceleration due to gravity is given. What we can do? Force is nothing but you have to calculate what? You have to calculate what is the depth. How much after falling here, how much depth it will go? How much deep inside the water it will go is the question. How can we solve this? Force is equal to mass into acceleration. So I can say acceleration is equal to, what is the acceleration? With what acceleration? If it is moving downwards, then we can calculate height, I think. So I will write acceleration is equal to force by mass. Okay, acceleration is equal to force by mass. What type of force is there in water now? That is upthrust force. Correct? Weight and upthrust force both will be there. So I can say total force acting on this ball at this point is upthrust minus the weight. Upthrust minus weight divided by mass. Upthrust minus weight by mass, if you calculate, you will get the acceleration. Once we know acceleration, I think then we can calculate height. So, what is the upthrust formula to calculate? How can we calculate upthrust force? Upthrust is nothing but force. How can we calculate force? Again, force is nothing but mass into acceleration. What is the mass now? Mass we don't know. We know in terms of density. So density is equal to mass by volume. Use that relation and calculate mass into acceleration due to gravity. So use this concept and try to solve this. Can you please try?